Right triangle trigonometry. The 6 trigonometric functions are sine, cosine, tangent, cosecant, secant, and cotangent. First, we consider right triangle ABC and angle theta. Sine theta is a quotient of a length of the side opposite to angle theta, A, to the length of hypotenuse C. So it's A over C. Cosine theta is a quotient of a length of the side adjacent to angle theta to the length of hypotenuse. And tangent theta is a quotient of a length of the side opposite to angle theta, A, to length of the side adjacent to angle theta, B. So it's A over B. Example. Find the value of the 6 trigonometric functions in the figure. So let's start with the writing. So here it is angle theta, and let's start with finding sine angle theta. Let's start with finding sine theta, but to find it we need to know the length of hypotenuse C. So to find it we're going to use Pythagorean theorem. Hypotenuse squared equals one leg squared plus another leg squared. So C squared is equal to A is 3, so 3 squared plus 4 squared. So we have 9 plus 16, C squared is 25. So C is square root of 25, what is 5. Sine theta is the quotient of length of a side that is opposite to angle theta, which is A, to the length of hypotenuse C. So 3 over 5. Now cosine theta, it's B over C. So 4 over 5. And tangent theta is 3 over 4. The quotient of side opposite to angle theta to length of the side adjacent to angle theta. Now we need to find 3 more trigonometric functions. Cosecant theta, secant theta, and cotangent theta. Let's jump to next page. Reciprocal identities. So what we can see here, sine theta is 1 over cosecant theta, and cosecant theta is 1 over sine theta. So they are reciprocals of each other. Cosine and secant theta, reciprocals. Tangent and cotangent, they are reciprocals. So we can easily find cosecant theta as a reciprocal of sine theta. So sine theta is 3 over 5. So reciprocal is 5 over 3. Secant theta is a reciprocal of cosine theta. If cosine theta is 4 over 5, then reciprocal is 5 over 4. And cotangent theta is the reciprocal of tangent theta. Since tangent theta is 3 over 4, then reciprocal is 4 over 3. Quotient identities. You can see that tangent theta and cotangent theta are reciprocals of each other. Now, let's consider this right triangle with a acute angle 45 degrees or pi over 4 radians. This triangle is isosceles, so 2 sides of equal length. And let's find sine 45 degrees. It's a quotient of the side opposite to 45 degrees to the length of hypotenuse. So we have 1 over radical 2. If we rationalize the denominator by multiplying top and the bottom of the fraction by radical 2. We get radical 2 over 2. Cosine 45 degrees is a quotient of the length of the adjacent side to the length of the hypotenuse. So it's 1 over radical 2. So we're getting the same as sine 45 degrees. And tangent 45 degrees is a quotient of length of opposite side to the length of the adjacent side. So we have 1 over 1, what is 1? Now, cosecant 45 degrees is a reciprocal of sine 45 degrees. So I use this value of sine to write reciprocal is radical 2 over 1, what is radical 2? Secant 45 degrees, radical 2, and cotangent 45 degrees is a reciprocal of 1, that is 1. Now right triangle with the angle 30 degrees or pi over 6 radian and 60 degrees or pi over 3 radians angles. So let's find sine 30 degrees. Is a quotient of the length opposite to this angle to the length of hypotenuse. So it's 1 over 2. Cosine 30 degrees is a quotient of the length of the side adjacent to this angle to the length of the hypotenuse. Radical 3 over 2. And tangent 30 degrees is a quotient of the length of the side opposite to angle and length of the side adjacent to this angle. So it's 1 over radical 3. Let's rationalize the denominator by multiplying denominator and the numerator by radical 3. So it's radical 3 over 3. Trigonometric functions of special angles. You just need to learn and memorize these values. The Pythagorean identities. So again, this identity you have to memorize. Now, these identities, it's nice to memorize too. But if you forget one of these two identities, it is no big problem, because using the first identity, you can always get these two identities. And I can show you quickly how we can do that. I write again the first identity, sine squared theta plus cosine squared theta equals 1. Now we divide both sides of this equation by cosine squared theta. We divide everything by cosine squared theta. And now we're simplifying each of these fractions. Quotient sine and cosine is tangent theta, but since we have squared, then tangent squared theta plus. This fraction is 1, cosine squared over cosine squared. And 1 over cosine squared. So 1 over cosine is secant theta. But since we have square, so secant squared theta. Here it is, our second identity. And the same way you can get the third one when you divide the main identity by sine squared theta. Now, example. Sine theta is 1/2 and theta is acute angle. Find the value of cosine theta using a trigonometric identity. So we start writing this identity. Sine squared theta plus cosine squared theta is 1. Since we know sine theta is 1 half, then we plug 1/2 into this identity. Now we simplify, and 1/2 squared is 1/4. Now we can express cosine squared theta as 1 minus 1/4. We subtract 1/4 from both sides. Cosine squared theta is 3/4. Then cosine theta is square root of 3/4. Or radical 3/2. Here it is the answer. Trigonometric functions and complements. Two positive angles are complements if their sum is 90 degrees or pi over 2. Okay, for example, if one angle is, let's say, 40 degrees, then its complement is 90 minus 40, 50 degrees. Any pair of trigonometric functions f and g, for which f of theta is equal to 90, g of 90 degrees minus theta, and g of theta equals f of 90 minus theta, are called cofunctions. Now you can see cofunction identities. Now what we need to pay attention on. So on the right side of each of these equations, the angle is 90 degrees minus theta everywhere. When on the left side is theta. And what else? So the function on the left side on each equation, turning to a cofunction. Sine becoming cosine, tangent becoming cotangent, secant becoming cosecant, and so on. Example. We need to find a cofunction with the same value as given expression. Sine 38 degrees. Cofunction for sine is cosine. And to find value of the angle, we just need to subtract 38 degrees from 90 degrees. So it's cosine 52 degrees. Find cofunction for cotangent pi over 20. The cofunction for cotangent is tangent. And to find the value of the angle, we need to subtract pi over 20 from pi over 2, from 90 degrees. But we have radians, so we use pi over 2. We need common denominator, what is 20. So multiplying 2 times 10 and pi times 10. Now we have fraction with a denominator 20 and the numerator 10 pi minus pi. So it's tangent 9 pi over 20. And the word problem. A telephone pole is 60 feet tall. A guy wire 70 feet long is attached from the ground to the top of the pole. Find the angle between the wire and the pole to the nearest degree. So we need to find this angle theta. Solution. So we can see we have a triangle, right triangle. To find angle theta, we need to use one of the trigonometric functions, cosine or sine or tangent. If we look at this triangle, what do we know? We know hypotenuse and we know the length of side adjacent to angle theta. So in this situation, we're going to use cosine theta. as a quotient of the length of the side adjacent to angle, 60 feet, over length of hypotenuse, 76 feet. But this is a cosine, but we need to find theta. So we're going to use inverse of cosine theta. So we can write little symbol, -1. It looks like degree, but it's not degree. Of 60 over 76. Now we're going to use a calculator. So when you're going to use a scientific calculator, the first step is to press on mode to be sure that we have more degrees than radians. The second step, press on second. After that, third step, press on cosine. And then type 60 over 76. And then we get a result 37.86364 and keep going. And we need to round this to the nearest degree. So to the nearest whole number. So here it is, but we have to pay attention on the next digit as 8. It's a big digit. Then we have to add 1 to 7. So we're getting 38. So the answer is 38 degrees.